Hello everyone, welcome to solve this nice math Olympiad geometry problem. And here we have a nice right triangle in which the length of one side is sine A and the length of other two sides are sine 2A and sine 3A. So we solve this problem for the values of A. So here if we suppose this is the any other angle, and we know that in right this triangle has one angle is 90 degree, so it means that this triangle is called the right triangle. So the side opposite to the right angle is known as hypotenuse, and the side which join these two angles is called the base, and the third side is called perpendicular or altitude. And we know that the hypotenuse theorem is the Pythagoras theorem is also applied to this right triangle. And we know about Pythagoras theorem. It is about hypotenuse square equals to base square plus perpendicular square. So this is called the Pythagoras theorem. So we have our hypotenuse is sine 3a, base is sine 2a, and perpendicular is sine a. So we put these three values here and we get its output in this form: sine of 3a and its whole square equals to sine of 2a and its whole square plus perpendicular is sine of a and its whole square. So here we use the trigonometric identities, and we know that sine 3a equals to 3 times of sine a minus 4 times of sine cubed a and its whole square equals to, we know that sine 2a equals to 2 sine a into cos a and its whole square plus the square of sine a is written as sine square a. So here we simplify the terms, and now first we open the square of this term, and it is 3 times the square of 3 is 9 and sine square a plus the square of 4 is 16 and square of sine cubed is 6a sine 6a and minus 12 times of sine to the power of 4a equals to, we open the square of this term, and it is 4 times of sine square a into cos square a plus sine square a. And now in the next step, first we focus on the right hand side, and now we convert all the terms in sine ratio. So we convert this cos square a into sine, and we write it as 4 times of sine square a into, we write this as 1 minus sine square a and plus sine square a. And now we multiply this 4 times of sine square a on both of these terms, and it will be written as 4 times of sine square a minus 4 times of sine to the power of 4a plus sine square a. And here we add or subtract the like terms, and we have 4 sine square a plus sine square a equals to 5 times of sine square a minus 4 times of sine to the power of 4a. And now in the next step we move these two terms from right hand side to the left hand side. So first we write left hand side. So our left hand side is written as 9 times of sine square a plus 16 times of sine to the power of 6a minus 12 times of sine to the power of 4a. And now we move these two terms in the left hand side, and it will be written as minus 5 times of sine square a and plus 4 times of sine to the power of 4a, and this whole equation equals to 0. So now in the next step we add or subtract the like terms. So here we first write the term whose greater exponent. So it is 16 times of sine to the power of 6a, and after that we have minus 12. So here we have little mistake. So if we open this square, so we get this is 24 sine 4a. So our this coefficient is 24 times of sine 4a. And now when we subtract minus 24 by plus 4, so it is written as minus 20 times of sine 4a. And after that we have this is the 9 sine square a minus 5 equals to plus 4 sine square a, and this whole equation equals to 0. And now in the next step you see here we have 4 times of sine square a be the common term, and after that we get 4 times of sine to the power of 4a minus 5 times of sine square a and plus 1 equals to 0. So here we write this 4 times of sine square a equals to 0, and 4 times of sine to the power of 4a minus 5 times of sine square a plus 1 equals to 0. So in this case, we easily get the value of sine A equals to 0. But we know that sine A be the perpendicular side of this right triangle. So it cannot be possible. The side length of triangle is 0. So that we rejected this case. And we can just proceed here this case only, and here we make the factors of this equation by breaking the middle term. So we write it as 4 times of sine to the power of 4a minus 4 times of sine square a minus sine square a plus 1 equals to 0. And now in the next step, here we take common 4 times of sine square a, and we get sine square a minus 1. Here we take common minus 1, and we get sine square a minus 1 equals to 0. So here we take common sine square a minus 1, and we get 4 times of sine square a minus 1 equals to 0. And now we convert this in two cases, so that our first case is we write sine square a minus 1 equals to 0, and we call this as equation number 1, and our equation number 2 is 4 times of sine square a minus 1 equals to 0, and we call this as equation number 2. And now first we solve our equation number 1, so that here we write from equation number 1. So equation number 1 is sine square a minus 1 equals to 0. And here we use the nice algebraic identity, and we write the sine square a minus 1 equals to sine a minus 1 into sine of a plus 1 equals to 0. So now we divide this in two cases. So our first case is we write sine a minus 1 equals to 0, and the second case is we write sine a plus 1 equals to 0. So in this case we easily get the value of sine a equals to 1. And you know that if sine a equals to 1, so this implies that the value of sine 2a equals to 0. And in this case, we get the value of sine a equals to minus 1. So in both of these cases, if you focus on the given question statement, we have sine 2a be the base of the right triangle and sine a be the perpendicular side of the right triangle. So it means that this is base and this is perpendicular. So we know that any side of triangle cannot be 0. So it is 0. So we rejected this case because it is not possible. And this is the another side length of triangle, and it is negative. So side length of triangle cannot be negative. So we rejected this case also, and we can proceed here equation number 2. So here first we copy down our equation number 2. So equation number 2 is 4 times of sine square a minus 1 equals to 0. And here we again use the algebraic identity, and we write it as 2 times of sine a minus 1 into 2 times of sine a plus 1 equals to 0. And here we divide further in two cases. So first is 2 times of sine a minus 1 equals to 0, and the second case is 2 times of sine a plus 1 equals to 0. And now first we solve the second case, and in this case we easily get the value of sine a is minus 1 over 2. And we know that sine a be the side length of triangle and it cannot be negative, so we rejected this case, and we can just proceed here this case only. And in this case we get the value of sine a equals to 1 over 2. And here you see that sine is positive, so we easily find the value of a. So now first we find the reference angle. You know about reference angle, it is the angle in first quadrant. So in first quadrant we know that all angles are positive, so we write it as sine inverse 1 over 2, and the value of sine inverse 1 over 2 is pi by 6. So this is the our reference angle, and you see here our sine is positive, and we know that sine a is positive, and it is lies in first and second quadrant, because sign positive in first and second quadrant. So in first quadrant our angle is pi over 6, and in second quadrant our angle is pi minus pi over 6. So in this case you easily get the value of a is 5 pi over 6. But here you remember one thing is that if our sine a is pi over 6, so we easily get the value of sine 2a is less than 0, less than or equals to 0. If a is pi by 6, then sine 2a is less than or equals to 0. So it means that sine 2a be the side length of triangle, it cannot be negative or 0, so that we rejected this case. We rejected this value, and we have just only one value of this question, and it is a equals to pi by 6. So if we write in general, we get a equals to pi by 6 plus 2 and pi, and over n belongs to r, any real number. So this is the final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.